Okay, we're back and we're going to finish up section 3. We're talking about factoring quadratics and solving. Okay, so here is part 2. So we've got this next example. A town has a nature preserve that they would like to expand. Originally, it was 400 meters by 600 meters. But they want to double the area. What should the dimensions be? So first, let's figure out what the old dimensions were. So this is right here. These are the old dimensions. And they want to expand them. So we've got some expansion here and some expansion here, where we expand the width this way and we're expanding the length this way so that it becomes eventually double. Okay, so let's figure out how this works. So if I'm going to set up something, we know that area equals the length times the width, right? Well, in this case, we want the area to be double what it was. So let's figure out what the old area was. The old area was 400 times 600, which is 24, or 240,000, okay? If we want our new area to be doubled, we're just gonna multiply that by 2, and we get 48,000. So we want our new area to be this, okay? So that's what we're gonna plug in right here. 480,000 equals, now the length was 400, but now we're adding a piece on, we're gonna call it x. So we're gonna call that 400 plus x. And we're gonna multiply it by 600 plus x, okay? So with that said, we're gonna make sure that we can solve by factoring. So here's the thing. We know our new area equals our new length and our new width, right? So what's going to happen is we're going to need to use FOIL for this first. Whoops. Here we go. We're going to FOIL this. First, outer, almost forgot a 0, and inner, and last, okay? In order to be able to factor and solve this, so if we're gonna solve by factoring, we have to have it set equal to 0. And right now, it's not. So in order to have it set equal to 0, we're gonna minus this over. So we're left with 0 equals negative 240,000, combine like terms. So now we have this we're going to factor, okay? I didn't give myself very much room, did I? It's okay. I'll just have to bring it down later. And we're going to go ahead and just put this in descending order, which just means I'm putting it in an order where the biggest term or the highest power comes first. And then this will come next, and this will come later. Okay, so now it's looking like something that we could actually factor, okay? So again, this is 1, 2, 3 terms. We know that this value in front of the x is a 1. So we're going to use our x factor. And we're going to say, okay, what factors of 240,000 equal 1,000? Okay. If we're looking for these factors, we could start at 1, but we know that's not going to be enough. We just know that the numbers need to be pretty close. They need to be 1,000 away from each other. And if we look at the factors of, basically, let's just take our factors of 24. We could use 1 and 24, 2 and 12, 6 and 4, okay? And we know that this is a negative. So we know that it needs to be by subtraction. So which of these factors could basically make a 10 by subtraction? See, it's right here. So let's put a 2 here and a 12 here, but remember, it's not 10, it's 1,000. So I know 20 times 120 can make 1,000. Okay, and actually, one more zero. There we go. Now we have enough zeros. And we need to know, okay, how's this going to work? Well, I know 1,000 was positive. So in order for them to add to 1,000, we're going to put the negative in front of the 200 because we know 1,200 minus 200 gives me 1,000, so we're good on that. And then negative 200 times 1,200 will give me negative 240,000. So there's our factor. And we've got x minus 200 here, x plus 1,200 here. Remember, in order to solve this now, we're going to use the zero product property, where either this or this have to be 0. So I know x minus 200 has to equal 0. X plus 1,200 equals also 0. And then we solve each. So we could get this answer for 200 as x, or we get x equals negative 1,200. Now, normally I'd say, okay, that's fine. But we're talking about a field here. Can a dimension be a negative number? No, it can't. So we know this isn't going to work. That's called an extraneous, extraneous solution. So if that doesn't work for us because we're using actual distances, distance can't be negative, this is our answer. So remember, the dimensions up here were 600 plus x, which we just found out that x was 200. So now this is 600 plus 200, which is 800, is our new dimension. And on the top, it was 400 plus, now this is 200. So that's a total of 600 meters. So our new dimensions are 600 by 800 meters. Okay. And then our last one, we're going to find the zeros of the function by rewriting it in intercept form. So find the zeros by writing it or rewriting in intercept form. So here we go. So remember that intercept form, if you don't remember, is y equals a times x minus p times x minus q. Basically, these are just factored, right? That's in a factored form. So the way that we can do this here is just by factoring. So we're going to factor this. There's no GCF. There's 1, 2, 3 factors, or 3 terms. So we know we're going to use our x factor. We're going to put this on top, figure out what multiplies to negative 12 and adds to that negative 1 in front of the x there. Okay, so you put your b term in the middle. Let's list our factors. 1 and 12, 2 and 6, 3 and 4. And which of these can make a 1, either by addition or subtraction? It's right here. And since I know this 1 is negative, the bigger value of our factor is going to be a negative as well. 3 plus negative 4 is negative 1, we're good. 3 times negative 4 is negative 12, so we're good there as well. So now we're going to factor it. X plus 3, because it's a positive 3, x minus 4. We set that equal to y. But remember, we're not just looking for it in intercept form. We're we're finding the zeros. So let's remember that a 0 are also the x-intercept. And what do we know about the x-intercept? We know that the value of y is 0. So if I'm looking for zeros, I'm basically going to set the y equal to 0. Okay, so to find the zeros, we set the y equal to zeros. So here's my factoring equation, and then look, now we can use the zero product property, where we know both of these have to be set equal to 0 in order for them to multiply to 0. And then we solve. So our solutions to this are x equals -3 and x equals 4, meaning zeros. Oh, that was the other thing. And up here, when I said synonymous, one more synonymous thing is solutions. Okay, so if they say find the roots, find the zeros, find the x-intercepts, or find the solutions, those are all the same thing as an x-intercept. I don't know why there's so many. We'll just write them down. All right, that's it for part number 2. I will see you